Solve the equation 8 to the power of x times 4 to the power of x squared minus 6, equals 4. So what do we have? We have an exponential equation, right? Exponential just meaning we have powers, right? 8 to the power of x, for example, and it's in an equation, and we're solving for x. So to tackle a problem like this, we want to get all of the exponential terms, or all of the terms, to have the same base. So remember, base is, let's say, x squared. The base is x. Or 4 to the power of 3. The base is 4. So looking at the terms given, right now we have base 8, base 4, and base 4. We want them to be in a common base. So could we write 8 as a power of 4? Right, 4 squared would be the lowest one, which is 16. So we can't. Which tells me, instead of 4, we actually want 2 as our common base. So how could we write 4 in terms of 2? As a power of 2. That would be 2 squared. How could we write 8 as a power of 2? That would be 2 cubed. So wherever we have a 4, we replace it with 2 cubed as the base. Whenever we have a base of 8, we replace it with 2 cubed. So let's do that now. We'll rewrite this exponential equation in terms of our common base. So instead of 8 to the power of x, we have 2 to the power of 3. So that's our 8, and that's still to the power of x, times, instead of 4, we'll have 2 to the power of 2, and it will have the same power, of course, x squared minus 6, equals, instead of 4, we'll have 2 squared. Like so. Now we're in business. We have an exponential equation, but all of the bases of the terms are the same. So now looking at the left-hand side, it's a bit more complicated, so let's use our power rules to simplify this. 2 to the power of 3 to the power of x. Powers of powers, we multiply. For example, you might have x squared to the power of 3. That's the same as x squared times itself 3 times, which is the same. I'm not going to write out all these x's, but it simplifies to x to the power of 6, which is just 2 times 3. So let's apply that idea here. 2 to the power of 3 to the power of x becomes 2 to the power of 3 times x. And we'll multiply that by 2 to the power of 2 times x squared minus 6. We'll just use brackets here because that whole x squared minus 6 is the power, so we need to multiply it by that whole term. Okay, we could expand this power out. So 2 to the power of 2x squared minus 12. When we multiply powers of the same base, for example, x squared times x cubed, we can add the powers. So in this example, x squared times x cubed becomes x to the power of 2 plus 3, which is x to the power of 5. So over here, we'll have 2 to the power of 3x plus 2x squared minus 12. So we added the powers to bring it into one exponent term. Alright, now, good place to be. We have an exponential term on the left, an exponential term on the right, and critically, they have the same base 2. So we can equate the powers. The powers being 3x plus 2x squared minus 12 and 2. So we can effectively eliminate the base. And next year you'll learn how to do it using logs, but for now we're just taking it for granted. So we equated the powers. Right, so we went from a messy exponential equation right down to a quadratic equation. Right, and that's what we're trying to solve now. So I'll put it into standard form. So that will be 2x squared plus 3x. Instead of minus 12, I'll subtract 2 from both sides. So that will become minus 14 equals 0. So I put our quadratic in standard form. So now we can solve it. So we can factorize our 2 sets of brackets equals 0. We have a 2 in front of our x squared term. So we're going to need a 2x and an x in order to get 2x squared. Now we need factors of negative 14. So that could be 14 and 1 or 2 and 7. But of course one of them will have to be negative. And so you'll just try a few different combinations. For example, 7 and negative 2 multiply to negative 14, tick. And then expanding this out just to check that we end up with that plus 3x. So 2x times x is x squared, great. 2x times minus 2 is minus 4x, plus 7x gives us plus 3x. So that works. So we factorized it correctly. But on this step, this is the step that might take a while, so just take your time and list out all the factors. Okay, we factorized it. Now we can solve. So either 2x plus 7 equals 0, or x minus 2 equals 0. So solving the first equation, subtract 7 from both sides, divide both sides by 2. We get x equals negative 7 over 2 as a solution. Or on the second equation, we could add 2 to both sides, and we get x equals 2 as our second solution. I know, that's a lot. You'll probably need a nap after this one. But the good news is this type of equation, or problem rather, is always very similar in terms of the steps, right? The first step, finding a common base, in this case, a common base of 2, then rewriting the equation with that common base, using our power rules to combine things and simplify it into one exponential term on the left equals another exponential term on the right, and they both have the same base. We could then equate the powers, which boiled us down to a quadratic equation, which we then solved however you like, right? Factorizing by grouping, by inspection, quadratic formula, whatever. And then that got us our 2 solutions for x.